Let's not forget that this time. That'd be a good idea.
Tell me when you've started recording.
I have.
Okay. F is equal to change in momentum. Ignore the random tick mark. Sorry, get rid of that. Change in momentum over change in time. Imagine I can draw T's.
Hey, you know who kind of looks like a T?
If you say
If you
Iron
say an
Golem,
iron
I'm gonna lose
golem.
my mind. Oh my
Okay,
god.
so you can use so momentum is primarily used in collisions, and a lot like energy, it's just this concept that we made to make things work. Um, but the general gist of it, obviously, as you can infer from P equals mv, is that a large, fast-moving object has more momentum than a slower and smaller object. Um, the biggest things with momentum itself is not that bad, but the problem with it, and what makes people think it's bad, is that almost every problem that you do with momentum is just boils down to a system of equations. Systems of equations are just annoying, just flat out. So for that reason, you kind of need to practice it a lot, because the key to solving momentum problems is figuring out which variables you're missing and what you know, and then figuring out what equations you can combine to um, solve it, so to speak. Um, so there are several different ways you can do it. The main hidden variable in pretty much all momentum problems is that momentum is conserved within closed systems. So if you have a system and it says either that it's closed or that there's no force acting, no external force on the system, then the change in momentum is always equal to 0. So if you have multiple objects in a system, then if one object loses momentum, the other object has to gain the exact same amount of momentum, because the total change in momentum has to be 0. If there's only one object in the system, then obviously the momentum of that object can't change. Any questions so far? Okay. The second the two things that they might tell you about systems is that it might be an elastic collision or it might be an inelastic collision. In an elastic collision, the change in energy is equal to 0. So again, if there's two objects and they collide or whatever, not only does if one object loses momentum, the other object has to gain momentum, but if one object loses energy, kinetic energy specifically, the other object has to gain energy. So that's an elastic collision. So that's one piece of information that they could give you, where you would have to then combine your momentum equations with your kinetic energy equations in order to solve for whatever the question is asking for. Are there any questions so far? Okay. The second type of collision is an inelastic collision. And in an inelastic collision, change in energy is not 0, right? So there's some gain or some loss of kinetic energy. If a question ever asks you about an inelastic collision, they have to give you either the starting energy, the final energy, or some way to find the starting or final energy. For example, they can give you all the masses and the velocities, or they can give you at the beginning, or they can give it to you at the end. Or they could say it's a perfectly inelastic collision. When there's a perfectly inelastic collision, it means that the two objects stick together. So like if you have a box, another box, and this box is speeding down, when they collide, the two boxes are just going down, and they've stuck together. They now have the same velocity. So in a perfectly inelastic collision, the velocity final of the first object is equal to the velocity final of the second object. So those are the conditions that they can give you when we're talking about momentum problems. Momentum will always be conserved within a system, and then either you're just going to have to use that fact, or they might say it's elastic, in which case you know that you need to use energy, or they can say it's inelastic, and as a subset of things inelastic, they might say it's perfectly inelastic. And so when they give you those pieces of information, or they say something that leads to you knowing that, like for example, if they say the objects stick together, you have to deduce that that means it's perfectly inelastic, then you can use the various equations and combine them to get your answers. That's mostly a review from last time, although I know there was like no one here last time. So are there any questions so far about the different conditions they can give you in momentum questions.
The elastic is that there is no change of. Okay, never mind. I answered my own question. Change in energy. Okay.
Yeah. So if it's an elastic collision, then if one object gains energy, the other object has to lose energy, and vice versa. In an inelastic collision, that's not true.
All right.
Okay. So, like I said, pretty much the main thing with momentum questions is just we have to practice, because all it is just finding the equations you need to use, and combining them to cancel out variables. So if everyone can go to the item pool link, that is, just scroll up. I'm not posting it again. In general chat. And Ellie, this question is for you because you wanted one.
Oh, you're gonna turn on the overlay for the
I
question?
will as soon as I pick the questions.
Ah, okay.
Are you recording, Alan?
Yeah, I am.
Wow, I did
Oh,
not pick the right
nice.
questions. I'm retarded.
I remember to hit the button this time. That does tend to help.
Alright, is it streaming the overlay? Of course it's not. Why would it ever do that? There we go. Okay. So here's the question. So remember, we've talked a lot about graph questions in the past and the different things you can deduce from graphs. So know the equations that I have conveniently left on the screen, and what you know in the graph to try and figure this one out. And like I said, this one's for you, Ellie, because last time we did this, you asked for another one.
Is there somewhere we answer this? Like a link?
Yep. If you go in general, scroll up a little bit, there's the item pool link.
Oh.
All right. So we'll give you a minute left. All right. Whoever hasn't answered yet, just make a guess, and we'll go on and explain it.
Well, everyone's picked the same answer, so that's good.
Yep, hopefully it's the right one. It's still only 3, but we'll just finish it. Okay, yes, so it was B. So does anyone want to explain why it's 2.4?
So using the formula that you gave, I multiply the change in time times the force in newtons to find the change in or the change in momentum using that formula. So I just used 15, which I was kind of unsure, is it 15 or not? But I just went with my gut. I did 15 as F, and the change in time is 0.24 minus 0.080, and that was 0.16 was the change in time. So I multiplied 15 times 0.16, I got 2.4.
Yep. So in this case, it's just the area under the graph. So we just need to find the area of that rectangle, and that's just gonna be the difference of the 2 times the height. Also on AP, if they ever give you graphs like this, and there's literally only one number on the y-axis, and the horizontal, where the point on the graph looks like it's approximately there, then it's that number. They will never make you guess. If they want precise numbers, they would add grid lines. So if it's a graph like this and it doesn't have grid lines and it has one number on the y-axis, then that's the number of the that the graph is at.
All right, that's good to know. Thanks.
Yep. Okay, are there any questions about how we did this question? All right. All right, just a minute or 2 left. Okay, if you haven't answered, try and give a guess, and then we'll go ahead and explain it. Okay. So this one was 3.6 kilogram meters per second. So can anyone who got 3.6, if you want to explain why it's 3.6?
Yes, it's just the area.
Oh my.
Yeah, so just like the last problem, it's the area. So a lot of people talking at once, sorry. Yeah, so just like the last problem, it's the area. So the middle rectangle was exactly the same as the previous problem, so you already know that that one was 2.4, I believe. And then you just need the area of the two triangles. So you just need to do 1/2 base times height for the first triangle, 1/2 base times height for the second triangle. The heights of both triangles are 15, and the bases are the difference of the seconds there. So the last one is 0.32 minus 0.24. The first one is 0.08. And then you just add that, all the two triangles and the rectangle together, and that's the area under the graph. And that is the change in momentum. Any questions so far about how we did these two questions, or these two problems? Okay. So let's go ahead and look at this one. All right, just a minute or two left. It's a multiple choice, so just make a guess if you don't know.
Woof.
Okay, so the key thing to notice is that the question did not say there were any external forces. It didn't say there was friction, and it said that they kept the same direction. So there was no external forces in this problem. For any physics question, in general, they pretty much have to explicitly tell you that there's external forces if there are. So since there is not, the change in momentum is 0, because when there's no external forces on a system, then the change in momentum is always 0.
But what if it's an uh elastic collision?
Doesn't matter. An elastic collision still
Yeah,
has.
even completely inelastic collisions, momentum is conserved. Momentum is always conserved in collisions. For the purposes of physics one, it's energy that is sometimes not conserved.
Oh, right. Okay, thank you.
The
Yeah,
problem.
the pretty much only case that you would get momentum is not conserved is if they said something like there's air resistance or there's friction. And in those cases, since the friction isn't applied and that's an external force, then momentum wouldn't be conserved. But that's really rare for that to happen.
Also,
And
if they
obviously,
did that, I don't think you'd be able to solve the problem
or
unless
they would
they
have to
unless
use
they
the
asked you, is momentum conserved?
yeah.
But
So,
like you wouldn't be able to use these equations if momentum wasn't conserved. So
but just as a general, especially if they ask you these kinds of qualitative questions, um, momentum is always conserved when there are no external forces acting on the system. Any questions? Alrighty.
So the initial momentum of that question was what was the initial momentum of that question?
I mean, I would have to go back and look. Yeah.
It's fine. It's fine. It's fine. We can do it after.
So it said car A is moving at 12 meters per second, and its mass was 1.5, so it's just 12 times 1.5 is the initial momentum of car A, and then car B is 6 times 1.5, and add those two together is the initial momentum of the system.
Okay.
So this one you have to, like, this isn't a direct momentum question, but it is a conceptual qualitative question that is very similar to questions you would see on the AP test. So you just gotta sort of think about what is the most reasonable explanation for a loss of kinetic energy in this situation. All right, just a minute or two left.
What's the potential energy formula?
Mass times gravity times change in height.
Okay.
All right, let's take a look. Nice. Okay, so let's go through this with process of elimination. I'm going to start from the bottom. So D says energy was lost due to work by gravity, due to the work done by gravity during the motion. So this is wrong because when you're dropping it, gravity is pushing the ball down. It's accelerating it, and the work done by gravity increases the kinetic energy, doesn't decrease it. C says energy was lost due to friction between the ball and the floor. And if you think about a ball going straight down onto the floor and bouncing back up, there really isn't any friction there because in order for there to be friction, the ball would have to slide on the floor and move in a direction that the floor can actually put friction on the object. So there's no friction, in any lateral direction or in any upwards direction rather, that would affect its kinetic energy in the vertical direction. So it's not C. B says energy was lost due to the work done by the ball pushing on the floor during the collision. Can anyone remind me what the equation for work is in relation to force?
FT cosine theta.
Yep,
Oh,
or
wait.
just, I
Okay.
mean, that's right. Just force times distance, and particularly force times distance parallel to force. When the ball bounces on the floor, does the floor move?
No.
Yeah, effectively not. So there's no work done by the ball on the floor because in order for that to happen, the floor would have to move. So and there's no work done on the floor by the ball, so that cannot be a source of energy loss. So the only one left is A. And if you think about it, when you put a bouncing ball on the ground, it changes shape, and that motion of it, squishing as it hits the ground, that's where the kinetic energy is lost, and that's why it doesn't bounce as high on the next bounce.
I literally animate this. A ball. Okay, I'm crying right now. I'm crying. I've animated this multiple times, and I still said gravity.
I mean, the key thing to reckon here is that work is always done in the opposite direction or it's done parallel to the direction of movement, but you can't, you're not losing here because it's pulling it down.
But then my question for it would be like, when things bounce, like really squishy things, which stretch out more, they bounce like, sorry for the dog in the background. They bar like they bounce like higher. Like if you drop a bowling ball, it doesn't deform, but it doesn't go back as high. Why is that?
Because so for that, it's all is that all output is heat for something like dropping like a bowling ball,
Yeah,
or
yeah. In
is
that
it?
case, it's all output is heat. So there's sort of a curve, if you will. So when an object is super hard and can't deform at all, it has no place to store potential energy. So and since kinetic energy can't go from negative direction to positive direction just instantly, it has to all get dissipated as heat. When an object is super squishy, it expels all of that energy as potential energy in the squish, and then nothing really happens.
It's like
There's not
dropping Jello
enough
on the
enough
floor.
energy.
Like it
Somewhere,
absorbs all
yeah,
of it and it starts bouncing around. But in
somewhere
between there, it
in the middle.
absorbs it and then pushes it back out onto the ground and uses it to bounce back up.
Okay, that makes sense. Thank you so much.
Okay, so is there any questions about why it's A? All right.
Is this the one long problem?
This, I mean, you are gonna have to write it out, and I believe you have to use systems of equations. I am solving it out on paper right now just to make sure I remember it, but I believe
Oof.
you do. Yeah, this is like the non-conceptual questions for momentum are kind of brutal, not because they're hard, but because they're long and annoying.
So basically, what I'm hearing is, Ellie, you're gonna get this wrong.
No, you should be
Same.
hearing is you're gonna try, and maybe you'll get it wrong, but you'll learn.
I'm getting wrong, bro.
Alright, that's 4 people.
Yep. So also I'll take back what I said. You actually don't need systems of equations on this one. I didn't notice that, but yeah. So let's go ahead and show it. Yes, it is B. Does anyone who got that right want to briefly explain why it's B or why it's 5?
It's 5 because momentum. It's
You know what?
the
Valid.
conserve.
Okay, valid, but there's one word that you have to talk about in order for that to be correct.
I mean,
Conservation.
No, Ellie. The, elastic, not inelastic.
sorry.
If it was
I'm
inelastic, you'd be wrong.
shut up! I'm trying my best.
Okay. So for one, you could just sort of like the numbers are 5 and 3, and there's 3, so the other one kind of has to be 5. But let's say you didn't know that, right? Let's say you wanted to actually work it out. So we could say, no, don't. I don't want to rename the board. What are you doing?
Well, also, it's important to note that you can do the 5-3-3-5 because it says they're equal mass. If it didn't say that,
Yeah.
then you can't do that. You have to solve for the momentum.
But let's say you wanted to solve it out for real. So the initial momentum P. Am I okay? Good. I'm not covered up by the overlay. So the initial momentum is equal to. Well, actually, before I do that, let's draw out the situation. So it says there's a mass A. Oops, that's not a pen. There's a mass A, and it's moving in the positive x direction with a speed of 5. And there's a mass B, and it's moving in the negative x direction with the velocity 3. So the momentum here, remember they have equal mass. So the momentum is going to be 5 times the mass plus negative 3 times the mass. Which is 2 times the mass. And I'm going to move it over so you can actually see. Or I'm just going to take off the overlay. Okay, so, and now it goes full screen. What the heck? Anyway, so
This is with the overlay off. It's full screen.
yeah, it just morphed. I don't understand.
I feel like it might be outputting as widescreen.
I'll try and figure it out later. Anyway, so then after the collision, it says that mass A is moving in the negative x direction with this velocity of 3, and then mass B is moving some way. It doesn't really say. And so then the final momentum is going to be negative 3 m plus some whatever velocity it is times the mass, right? And remember we said that there's no external forces, so change in momentum is 0. So this whole thing, let me write a better m, still has to equal 2m. So then we can divide everything by m, so we get negative 3 plus x is equal to 2. We subtract negative 3 from both sides, and that gets us x is equal to 5.
Ayo, I did it totally differently.
What did you do? How'd you do it?
M1 V1 plus M1 V2 equals M1 V3 plus M1 V4.
mean, it works.
and I factor m, and then I just get
You're like
velocity
fading
3
in and out.
4.
Yeah.
Hold on, let me just send it in, Jen.
No, but
Typical
with
Tay
with a
Hungry.
lot with almost all physics problems, there's multiple ways to do it. So
Yeah. It's just
as long as you combine the
there for most problems there happens to be one way which is easier than the others. But if you find a way that works easier for you, then as long as you get the right answer, it doesn't matter.
All right, now it's like this with no borders.
What?
I don't understand.
Did you change anything?
No, I just turned it off and back on.
I put what I did in, Jen.
Yeah, so that's actually like mathematically the same as what I did. I just kind of split it up into two equations.
Yeah.
Okay. So let me grab another question for us. Sure. Let's do these 3, these 4. I don't know if we'll get to all 4, but we'll start. All right, just a couple more minutes. Just as a little hint, you're gonna have to combine things from outside of momentum to solve this question. So if you haven't figured it out yet, it's multiple choice. So go ahead and make a guess, and then we'll talk about it. All right. Okay, so most of you did get it right. Does anyone want to explain why it's 120 newtons? Well, actually, everyone got 120, but I don't know if that was a guess. But either way,
Okay, so it's 120 because two answers have one. Funny, but the reason it's up and it's not down is because the floor is going against the ball, which is going down, which means it has to be going up.
Right, it's
And
the
it can't
force
be
exerted on the
33.
ball, not the force exerted on the
Yeah.
floor.
Yeah, and the thing is that it can't be 33 because then the ball would go like straight through the floor, wouldn't it?
I mean,
It doesn't cancel it. It has to
it,
cancel it to
it,
go
well,
back
it,
up.
it it wouldn't stop in 0.45 seconds, or wouldn't.
Yeah,
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 it would
yeah,
stop in
yeah,
0.45
yeah,
seconds.
yeah.
But yeah, so I mean, yeah, you could have deduced it by the fact that there's two of them, and like that gets into the whole thing of there are 100% guessing strategies on tests, believe it or not, especially AP tests, especially like PSAT, SAT. But that's not a conversation for today.
although
As far as how
that
you
might
actually
actually be
solve,
something we should go over.
yeah, when we do the actual full-length practice test, we'll
Yeah.
talk about it. But anyway, so the first thing we need to know is the velocity of the ball, and that's not given to us in this question. So can anyone tell me how we get the velocity of the ball?
There are two right answers I can think of.
Kinematics.
That's one of them.
Yes, kinematics.
That's not how I would do it because I like making more work for myself, but
What's the way you do it?
energy.
Oh, that's lame.
Yeah, I'm gonna have to ban you, Alan. Yeah,
Wow.
my answer was going down and seeing that there were two answers.
All right, so as far as getting the velocity, we would do, if you look at your AP formula sheet, it is like the third equation, which is that V, or you could do energy, but we're gonna do it this way. This is the way I did it. V squared is equal to 2 times A, which in this case is 10, times change in X, which in this case is 1.5. And so that's V squared is equal to 30.
Why are
And
you
then
finding the velocity in the first place?
because you need that for momentum. Now, okay, so I'm fully aware you can in fact solve this problem without momentum. You could do it with acceleration since you know the mass. However, try if you this question is like 10 times easier with momentum because there's less equations. But that comes back to there's multiple ways to solve a problem, right? This isn't the momentum unit, so our intention was for you to solve it with momentum. But you could have just done it with acceleration. It would have just taken you longer. There's always multiple ways to solve a question.
Okay.
But so square root of 30 is V is equal to like 5.4748. No, not blue. 5.48. Okay, so now that we have the velocity, we can get the initial momentum. So the initial momentum is going to be what? How can we get that? Anyone remind me what the equation for momentum is?
M times V.
Yep, so the mass is 1, the velocity is 5.48, so the momentum is, gasp, 5.48. And then at the end, it says it comes to a rest after 0.45 seconds. So its final momentum is 0, making its change in momentum 5.48 or negative 5.48, depending on how you look at it. But its change in momentum is 5.48. So lastly, it says that it came to a rest in 0.45 seconds. And if we remember, force is equal to change in momentum over change in time. So we can say that the force is equal to 5.48 over change in time, which is 0.045. And that's going to give you your force of 120. It really gives you like 121 point something, but that's the closest answer. And like Ellie said earlier, the reason why it's up is because it asked what is the force exerted on the ball by the floor. And in order for it to slow it down, the floor has to push back up on the ball. Sorry, I realized that was off the screen. My bad.
Yeah, and you gotta be careful about that because if it had said what's the average force exerted on the floor by the ball, then C would have been right. and they could easily. That's not something I would not expect them to ask on a test. Like,
Thanks to the double negative.
shh. That is something I would expect them to ask on a test. They could do either of them, and you just gotta pay attention to which one is which.
Yep. Okay, so are there any questions about um, how we got the answer to that question? All right. It's probably gonna be the last one for today. All right, so are you guys just changing your answers until you see you all have the same answer?
If you are, that's not a valid test strategy.
Because I see,
No,
I saw,
bruh. I didn't. I know. I have not changed my answers at all.
Okay, we got one of the
Okay.
four.
because I saw different answers and then they all changed them.
I haven't
Next-
even answered.
Okay, so well, there's 3 left. I mean, it's fine, but just letting you know that ain't helping much.
It's also not helping us because we don't know how many people had the wrong answer, because we don't know who is entering what.
I didn't even know you could change your answer. I just selected something and I looked off the screen.
Okay, well, if maybe genuinely people just changed answers, but I kind of don't think that's the case since it just magically changed from 3 different answers to the same answer.
Yeah.
But anyway,
Yeah, I haven't changed my answer.
all right, I don't know. Just
That
as
leaves
long
me.
as... Rip. Anyway, if you haven't picked already, whoever's left, which I think was Sahil, guess.
Oh.
All right. Well, you picked the same as everyone else.
Oh my, that was.
And it was wrong. Nice job. That's what
Wow,
happened.
y'all are trash, bro. I'm just kidding. I
Alright.
actually, I didn't even look at the. I wasn't even looking at your screen at the time. I was looking at my other screen.
All right, maybe it was just luck. All I know
Yeah.
is I saw different answers and they all just converged. That's all I know. But anyway, so we need to know we need to know how high it was. So the first thing we need to find is the velocity. So again, remember that force is equal to change in momentum over change in time. And so it is 750 is equal to the change in momentum over 0.018 seconds. We multiply 750 by 0.01 or by 0.018, and that leaves us with change in momentum. Oh, there's stuff over here. Whoops. Move it over. Change in momentum is equal to 13.5. And so now that we have the momentum, how can we get the velocity that it was before it hit the ground? Anyone remind me what the equation for momentum is?
P times V.
Yep, mass times velocity.
I mean M times V. My bad.
Okay, mass times velocity. So it's going to be 2.4 times velocity is equal to 13.5. And that gives us a velocity of 5.625. So now that we have velocity, we can plug it into the equation we used before, which is v squared is equal to 2a change in x. So v squared is 31.64 is equal to 2 times a, which is 10 in this case, times change in x. Then we just solve for change in x. And so we just divide 31.64 by 20, and that should give you a, which is 1.6. More specifically, it gives you like 1.58, but it rounds up to 1.6.
So something that I find interesting here is that this is like really similar to the last problem. It's like working backwards almost of the last problem. Um, but everyone made the same mistake. So I'm curious as what was the mistake that everyone made?
My stupidity.
Okay, great. But what numbers did you mess up? Like where did you deviate from what Nathan did?
Oh, I did some dumb crap. I did P. So P equals MV. I thought that we had to find the meters in velocity. So I did P equals 2.4 times M over 0.018, and I just stopped there because I got confused.
Okay, did anyone else like follow through with their math and get the number that was their answer, or did everyone else just kind of do math and give up? I mean, it's fine.
Do math and give up.
Okay, so I'm gonna get the consensus that that's what everyone did, which, I mean, okay, we're still learning. But is there any questions about how I showed you how to solve this one? Okay, I hope that it's genuinely no questions and just that you don't want to, not that you just don't want to ask. But all right, so that's it for today. So next meeting we're gonna do more of these questions until hopefully we start getting them right consistently. Like I said, momentum is pretty much just you have to do tons of practice problems because it's just a matter of figuring out what equations to use. That's pretty much all momentum questions end up being.
Alright, I'm gonna stop the recording there.
Alright, thanks, man.